Right. So just to run over discrete distributions, the four discrete distributions that we need to learn is the uniform. How do we identify a uniform distribution? All the probabilities are the same. Geometric, how do we know it's a geometric distribution? They're trying to find the number of trials needed to get the first success. And these are all the formulas they need to be able to find probability. Binomial, similar to geometric, but it's the number of successful outcomes in n trials. So if you have 20 trials, number of successes is 6, then your probability is 6 on 20. In a geometric now, if it takes 6 trials to get your first success, right, then you find the probability of that happening. Then your P will be the probability of that happening, right? Okay, and these are the formulas needed to find expectation and variance and probability. Then Poisson is a little bit different. Poisson is characterized by a mean in a particular interval. So you write it like this. If the mean is, let's say, 5 grade 1s every year, right, then your mean will be 5. And the interval is a year. So if it changes to 2 years, your mean is now 10. So you have to pay attention to where your interval is, right? And then it shows you how to find probability, E of x, and variance of x. Right? As I was telling you all, just like unit 1, when n is too large, that means n is more than 50, right? Here we could also do, because the Poisson shape kind of normalish, right? When n is bigger than 50 and p is less than 0.1, the binomial distribution could be approximated the Poisson. And I want you to be careful here. You hardly see this, but if you do see it, I want you to remember that you're going from a discrete, which is binomial. You're going from a discrete distribution to our next discrete distribution. So you're going from binomial to Poisson. Because of that, there is no continuity correction. None. Right? Because it's not continuous, it's discrete. So if ever you see this, don't apply continuity correction. Just use the same x value they give you. Okay? So those are the four distributions that we need to learn. Those are your discrete distributions. Now, we're going to questions to try to figure out how to apply it, right? Go back to your summary and you'll get your formulas and thing, right? All right, now these things were kind of bad. Bling, bling, bling. Bling, bling, bling. Bling, 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 bling. Right, ignore that. Ignore that. Take a read here. Let's see what distribution we'll use here, right? Right, that's long enough. If this thing not working, then something is wrong with my pencil. Just so this thing stop working, right? Hey, boy. Oh, well, I gotta work with finger. Right, so 5% of batteries produced by a certain company are defective. So that's 5%, right? I'll write with my finger, I told you. On a particular day, batteries produced are inspected until the first defective battery is encountered. Let X denote the inspection number on which the first defective battery occurs, right? So, Darian, what type of distribution do you think this is? Darian said it looks pew, 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 doo, 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 doo. Where did Darian's comment go? Did it disappear? It disappeared. All right, found it back. He said it's geometric and he's quite right. X follows up geometric. And the probability is what, Darian? 0.05. You're smart tonight, boy. Next, the way to find the probability that the first defective battery occurs at the fifth. So find the probability of X is equal to 5 from him. Find the probability of X equal to 5, message a value. Just to get a value already. Wait, I no calculator here. Jada, tell me what you got? Work out something for the people there, by Jada. I will see what you got, boy. She don't tell me what you get. Right, so most of you will recognize already that is Q to the R minus 1. Q will be 0.9. Good job, Damian. 0.95. Right, 0.95 to the power of 4 by P, which is 0.05 to the power of 1. Right, and most of you all got 0.4. What's that you all said there? 0.04. 0.407. Because you said 0.4. 0.04 you all said? Right, 0.04, right? Right, I think it have one more little piece there. Determine the probability that the first defective battery occurs within the first 3 inspections. Within the first 3, right? We'll cover that fast. Within the first 3 means 3 or less. So that's the probability of X is less than or equal to 3. Right, work out that message answer. How much? I didn't see all again. What I get for that one? 1 minus 0.95 all cubed. Anybody could do me a favor and send some older years in like 17, 18, like if you have those junior 2 years, just send any group now, please. I not see any link I had with all of them. What y'all got for this one? 1 minus 0.95 all cubed. Zero point five four. Right, so yeah, you just plug it in 1 minus 0.95 all cubed. Right, that's just the formula I gave you. Right, Jesse got 0.548, right? So I just put in 0.55. Right, let's go again. Oh, they want the expected value. Still have more. Do part 4 and 5. Come on, and finish, right? So we're corrected. Same question, right? They want the expected value of x. You're done? Or they say nothing? So expectation, since it's binomial, expectation is E of x's, 1 on P. P was 0.05, so that's 100 over 5, which is 20. So the expectation is 20. Right? Then they want for the 20th inspection. We all the way there. So the probability of x is equal to 20. That will be 0.95 to the power of 19 by 0.05 to the power of 1. How much y'all got there? Hey. How much you get it, Jesse? Jesse said 0.019. All right, 0.019. Okay, so that's the way you work it out, right? Once you identify as a geometric, you use those formulas. The problem is more to learn, right? You gotta learn all those probabilities. That'll come on a formula sheet. Okay, so you have to learn all of that. This is normally distributed. Although you can do that first part, huh? Let's try this one here now. That's all in this? Same here, same here. Let's try the part here now. Any answers? You're done? Right, so by now you recognize the keyword weekly average. Right, the weekly average number of bad checks in a supermarket is 3. Right, so we recognize that that value there is 3. So that's, when you see the word average, 3, and is per week, right? Week is time. Because every time change, lambda will change. Okay, so suitable distribution X follows a person with lambda 3. Determine the probability that a supermarket will cash no more than 3. So the one, the probability of X being less than or equal to 3. No more than 3, right? Less than or equal to 3. And then we have to use the formula. The bad thing is there's no short version for this. So we have to find the probability of X equal to 0, probability of X equal to 1, probability of X equal to 2, and probability of X equal to 3. And we have to do it individually, right? So I'll do starting up here with 1. So for the 0, it will be e to the minus 3 by 3 to the 0, because it's 0 first, right? And I do this one here for you. So you can write them out and then put all in the calculator. 0 factorial is 1. Right? And then you add it to all the others. Work it out, tell me your answer. Right? Remember the question said that it will cash no more than 3 bad checks in a particular week. So because it's a week, lambda is still 5. And because they said no more than 3, you're doing it for 0, 1, 2, and 3. And no shortcut in this one. Do you think? Sign your values. Yeah, lambda is 3. Yeah, Chelsea? Lambda is 3. And this question, they want X less than or equal to 3 as well. Oh, I said 5 by mistake. Oh, sorry. Right, the weekly average number of bad check cash by a supermarket is 3. So lambda is 3. Work it out. Right? Should have answers by now. You're just plugging them straight into your. What you all got? Right, you're doing it for 0, 1, 2, and 3. 0.64. Anybody else get that? 0.647. Okay. Anybody else? Right. If anybody have, right, I don't know. I lost everything from them older years. When I had all the links to all the past papers. If anybody have like 16, 17, 18, 19, or those years, just send it back in the group now, please. All right. All right. Just squeeze in one more by Darian. You can squeeze in one more. Since technically you didn't really do that one. You was on your phone talking to Dumpling. We could do one more. He's still talking to Dumpling, right? All right. All right, Tolia. So we'll do some more of these and then we move on to the continuous. Right? Continuous a little bit longer. Right? We'll do some more discrete because here's what has happened, right? This one's straightforward. But sometimes they will ask the same thing. No more than 3, but then they will say in a particular month. So you have to know, okay, in a month of 4 weeks. So now the person will no longer be 3. It will be 3 by 4, which is 12. So your average value will change. So you have to look at the little wordings. The little wording could be could tie you up sometimes. Okay? So we'll do some more of those next day, right? At least when I come to class. That was good. Right? Last week I had a double unit 1. That's why I've canceled all you. So the older papers on. I know, but just download them and put them on the group now so we don't have to go there and search for it. I had just downloaded the last 12, 15 years and just leave them on the group. But I don't have access to that whole group again. I changed my phone. Right? So you could just get them and download them and put them there. So we have them to use them. The last 3, 4 years, they could lead up a crash course. We will do the one things and that kind of new part. All right. So that's it there. Right, you can log out next week.